Okay, so we're going to talk today about the perfect square. Now, a perfect square is basically when you have two whole numbers that you multiply together to give you another number. So, for example, 5 times 5 is 25. 5 by itself gives you 25. So, 25 is a perfect square. But what happens in the context of a simple binomial equation, right? So first, let's start by looking at our quadratic equation, which is right here. So ax squared plus bx plus c. Okay, what we're going to be doing today is variations on achieving that. So let's say you have ax plus b, which is a simple binomial, and you multiply it by itself. Okay, now we're going to do this once with basically in this case it's the same binomial multiplied by itself, but there's another scenario where it could be ax plus b into ax minus b. So you'll notice here that they're different sign conventions, right? But here they're both the same. So I'm going to show you so you can have a better idea of what a perfect square looks like in the different sign conventions. So if we multiply this out, I'm not going to go through all the details. I'm sure you could do it yourself. But basically, you're going to end up in this case with ax squared plus axb plus bax plus b squared. Okay, in this case, we're going to simplify this further. So a squared x squared, okay, plus 2 abx plus b squared. Okay, so let's do this guy out so that we can discuss this a little bit. So you're going to end up in this case with ax squared minus axb plus bax minus b squared. Now you'll notice that in this case, these guys cancel out, right? The middle terms. So if you keep going, minus b squared. So notice the difference, right? You have an extra whole middle term here that you don't have here, that's missing, all because we switched our sign convention. So let's do a very simple example. Let's do if we say x plus 2 into x plus 2, right? You're going to be left with x squared, sorry, that's a bad x, plus 2x plus 2x plus 4. Simplify this further, x squared plus 4x plus 4. Now, in this case, let's do x minus 2 into x plus 2. Basically, you're going to have this. So if we simplify this further, you're going to have x squared minus 4. So again, notice the difference. This is the main formula. This is the example, main formula, and the example. So notice how the whole middle term is not there. It's always going to be the product of two binomials that are of opposite signs, okay? So in the future, you could just go, even if you're not sure what is the square root of 4, you know that it's just going to look something like this. X plus something and x minus something, okay? So let's look at some examples together. So let's say you're given x squared minus 4 is equal to 0. Okay, well, the first thing you might say, well, I can just move that over, right? And I do x squared is equal to 4. You're right, you can. So that's going to be equal to x squared plus or minus the root of 4, which means that x is equal to plus or minus 2. So essentially, either x can equal 2 or x can equal minus 2. But if we think of it as an equation, we have to move the 2 over. So x is minus 2 in this case, equal to 0. And x plus 2 is equal to 0. So really, what do we have? We have x minus 2 and x plus 2 is equal to 0. So this, again, is the exact same format that I showed you earlier that it should be in, right? It should be x plus something and x minus something. Or, like up here, ax plus b into ax minus b. Okay, so let's look at another example. So x squared minus 25. So again, instead of doing all of this, you know that it's going to be x plus something and x minus something. Why do you know that? because you know that this is a binomial to the second degree terms in this equation. So you know right away that it's going to be x plus something and x minus something. So why x? Because x squared, so two x's multiplied together gives you a squared. And what's the square root of 25? It's 5. So very simple, x plus 5 and x minus 5. Okay, let's look at another one. So let's say you have 4ax squared minus 36. Remember, your first goal always in math is to see if you can simplify. That's the first thing you should always do when you look at something. In this case, can you simplify? Yes, because the 4 also goes into 36. So let's take that out. So that's going to be 9, right? 4 times 9 is 36. Now you have a squared minus 9, which is the same format that we've seen together just now. So let's simplify this further. So 4, so it's going to be a plus something and a minus something. So what is the square root of 9? It's 3, right? So that's going to be 3 and 3 right in there. That's it, you're done. So let's do one more, last one. Let's say you have x to the power 4 minus 16. So what do you do in this case? So can you simplify this? Not really. But you notice that there's something different here. You have, instead of an x squared, you have x to the power of 4. And you know 2 times 2 is 4. And you know that root 16 is also 4. So let's break this down. So there's probably going to be a few breakdowns that we're going to have to do here. So in this case, x squared minus something, right, into x squared minus or plus something, right? So what is the plus something? What's the root of 16? Is 4 and 4. So are we done here? Can we break this down any further, or is there something else we can do? In this case, remember, when you look at a binomial to the second degree or a quadratic with a negative, you know that you can always break that down further. So in this case, your x is going to be minus something, and x is equal to plus something. And this guy here doesn't really change. You can't break this down any further. You can try, but you won't get there because it's a positive, not a negative. So that is going to stay the same, x squared plus 4. So when we're looking at x squared minus 4, how can you break that down? It's going to be an x and an x into a, what's the square root of 4? Is 2. So it's going to be minus 2 and plus 2. And now it's finished. You cannot break that down anymore. Okay, hope that helps.